Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 10 of International A-Level Edexcel P3 January 2022 paper. So the question says that figure 3 shows a sketch of the curve C with equation x is equals to y multiplied by e raised to the power 2y, where y can take any real values. The requirement of part A is to show that dy over dx is equals to y divided by x times 1 plus 2y. Alright, so equation of the curve is x is equals to y multiplied by e raised to the power 2y. So first of all, what we are going to do, we are going to find the dx over dy function. We are going to differentiate x with respect to y. And once we are able to get the dx over dy function, then we can find the dy over dx function by this formula, 1 divided by dx over dy. So as you already know that we have two terms, one is algebraic and one is the exponential term, and both are a function of y. Okay, so we need to differentiate these terms with respect to y. So we are going to use the product rule formula to differentiate them. So we can say that u is equals to y, therefore u dash is equals to 1. V is equals to e raised to the power 2y. So therefore v dash is 2 multiplied by e raised to the power 2y. So as we know that equation of the curve is given to you in the form x is equals to u times v, where u is a function of y and v is also a function of y. So dx over dy will be equals to uv dash plus vu dash. uv dash plus vu dash. Okay, so u times v dash, this is supposed to be y multiplied by 2 times e raised to the power 2y plus vu dash, which is supposed to be e raised to the power 2y. So far we have achieved this thing. So therefore we can say that dx over dy is equals to 2y multiplied by e raised to the power 2y plus e raised to the power 2y. Okay, so far we have achieved this thing. So now if we take e raised to the power 2y as common, we are left with 2y plus 1. So as we want to find dy over dx, therefore dy over dx will be equals to 1 divided by dx over dy, which means 1 divided by e raised to the power 2y, and e raised to the power 2y is completely multiplied by 1 plus 2y. And as you know that the specific form which is required in the question, uh, as we can see that we have a variable x as well. Okay, so we are going to use the original equation of the curve. This means that we need to replace something in place of e raised to the power 2y. So since the equation of the curve is x is equals to y multiplied by e raised to the power 2y. So if we make e raised to the power 2y the subject of the equation, this will be equals to x divided by y. So in place of e raised to the power 2y, we can write x over y. So I'm going to continue the working at the top. Okay, so therefore dy over dx will be equals to 1 divided by, in place of e raised to the power 2y, we are going to write x over y, and this is completely multiplied by 1 plus 2y. So y will come in the numerator now, and therefore we are going to say that dy over dx is equals to y divided by x times 1 plus 2y. This is supposed to be our final answer. We need to show this particular form. So this was part A. Alright, so now let's move on to part B. Before part B, we have some information. It is said that given that the straight line with equation x is equals to k, where k is a constant, cuts C. C is basically the curve, cuts C at exactly 2 points. Part B requirement is to find the range of the possible values of k. So now if you see the points origin and onwards, we have the shape of the curve like this. And if we make any vertical lines of x is equals to k, so the lines would be something like this. Okay, so we would have only one point of intersection in all of these cases. So this means we are not interested in these lines at all. And if I make a vertical line over here of x is equals to k, we would have one point of intersection with the curve, one root. So this means that in this case, the vertical line would be a tangent to the curve. So this essentially means that the line would be something like this, which would give you 2 points of intersection with the curve. So this essentially means that k is supposed to be less than 0 at any cost. Okay, and k will be greater than a particular value, and we are interested in finding the value of k for which x is equals to k will make such a vertical line, this black line, at which the line of x is equals to k will be a tangent to the curve, all right, such that k will be greater than this value and less than 0, all right. So what we need to do in this case, we need to find this value of k first. And since I've already just mentioned that x is equals to k, this vertical line would be a tangent to the curve. Okay, so this vertical line will have a gradient which is undefined. So how to get any undefined value? Dy over dx will be equated with anything divided by 0. Let's say a divided by 0. So dx is basically equals to 0. So in order to get an undefined gradient, we need to equate dx with 0. Okay, so as we have already shown that dy over dx is equals to y divided by x times 1 plus 2y. So therefore, when dx is equated with 0, so x multiplied by 1 plus 2y is equals to 0. All right, so first we have x is equals to 0, and we are not interested in the origin point, so x is equals to 0 will be ignored. It will be rejected. Okay, so we are interested in 1 plus 2y is equals to 0, so therefore y is equals to minus half. So at y is equals to minus half, we need to see what is the value of x, and that will be the value of k, which we need to find first. So now what I'm going to do, I'm going to substitute y is equals to minus half into the equation of the curve. So I'm doing the working on the top. So x is equals to minus half multiplied by e raised to the power 2 times minus half. So therefore we can say that x is equals to minus half multiplied by e raised to the power minus 1. So therefore we can say that x is equals to minus 1 divided by 2e. So now we can say that this is basically the equation of x is equals to minus 1 divided by 2e. The equation of this vertical black line is x is equals to minus 1 divided by 2e. So therefore, this essentially means that k is greater than minus 1 divided by 2e, less than 0. K cannot be equal to 0, and it cannot be equal to minus 1 over 2e. Okay, because when k is equals to minus 1 over 2e means that this vertical black line x is equals to k will be the tangent to the curve. Okay, and here we would have only one point. Here the line x is equals to k meets the curve. So it will be only one particular point. We need exactly 2 points. And when k is equal to 0, so x is equal to 0, this y-axis will also have only one point of intersection. So we are interested in exactly 2 points of intersection. So this essentially means that k must lie in this region, which I am shading. So this is basically our required interval of k, which is basically the interval of the values of x. Since x is equals to k is the vertical line by which we are comparing the equation of the curve, so therefore your answer is that k is greater than -1 over 2e less than 0. All right. So this was basically question number 10 of International A Level Edexcel P3 January 2022 paper.